One full year has elapsed since the boat tragedy occurred in the picturesque freshwater lake nestled in the National Tiger Reserve of Thekkady in Kerala. What started as an enchanting cruise along the lake turned out to be a watery grave for 46 tourists, including 15 children. There were parents who lost their kids, newlywed who lost their partners, and children who became orphans. Tourism in Thekkady is still alive and kicking. So also are the boat cruises. However, the post-boat tragedy period has shown a decline in the number of tourists, both foreign and domestic, visiting Thekkady. The overall trend in Idukki district, where this lake is located, was more or less the same in the last tourist season compared to the previous one. While the records show a 10 to 15% decline in the tourist arrivals in Thekkady from October last year to May this year, tourist inflow into the adjacent tourist towns in the district, like the tea town of Munnar, registered an increase by the same percentage. During January-February, the main tourist season in the district, the decline in tourist arrivals in Thekkady in comparison to the previous year was glaring. Has this got anything to do with the one-year-old boat tragedy? Have we learned real lessons from the tragedy? If we had, why are not the Thekkady boat cruises back to its old glory? Now, let's have a quick flashback. On 30th September 2009, tragedy struck when a double-decked fiber boat capsized in the picturesque freshwater lake nestled in the National Tiger Reserve of Thekkady in Kerala. What started as an enchanting cruise along the lake turned out to be the watery grave for 46 tourists, including 15 children. There were parents who lost their kids, newlywed who lost their partners, and children who became orphans. According to the survivors, the boat capsized while maneuvering a turn in the deep waters. There are several versions about the cause of the tragedy. The most probable theory goes like this. Tourist boarding the boat. Boat cruising smoothly over the lake. Someone shouting from the upper deck after spotting some wild elephants. Others from the lower deck crowding and concentrating on one side to have their first glimpse of the wild elephants. The boat driver takes a deep turn. As a result, the boat loses its balance and capsizes. Hapless victims fall into the water and struggle for life. Many are still trapped in the lower deck. Rescue operations are on. Is it just human error or overcrowding of tourists on the upper deck, or a sudden burst of wind that caused the tragedy? There are some crucial questions that need answers in the case of any such tragedies involving boats of any kind. Was there something basically wrong with the design of the boat itself? Was the boat in good condition? Was the boat suited for this kind of cruise? Was there something technically wrong with the boat? Were the rules and regulations being followed? The boat capsizing incident has shaken the state tourism. Many questions have been raised on the insurance aspect of the boat. Why didn't the authorities take necessary steps to ensure that the boat has been properly insured? Or is it that there is no insurance needed at all? Tourism has broken traditional barriers by introducing fiber boats instead of the traditional wooden boats which have been drifting in the backwaters for many long years. The rules and regulations of the bygone time have definitely affected the boating scenario. Let's hear another perspective of this tragedy by our expert.
It's a total system failure due to ignorance from top to bottom. How can you complete the registration process without insurance? It's a shocking thing that a vessel is running without insurance. Who is responsible for paying the compensation? As per Airlines Convention or MS Act, the owner is responsible to pay the entire compensation. Unfortunately, the MS Act says only to pay rupees 100,000. It's nothing. It was made in 1958. Can you still follow those rules? And it was made for the sea. And this is a totally different situation. It's a calm water. Basically, it's a lake. We need to have some latest rules, regulations for the inland navigations. But which rule we will follow? We need to adapt something suitable for our waters. If we don't do that one, we will try to import some rules from abroad or some other system, and it will never ever suit with the traditional boat building and traditional boats of this state, and it will be the end of the tourism of this state. This state attracts the tourists just because of the beauty of the backwaters and the traditional boats, and the traditional boat building is totally different with the modern shipbuilding. Traditional boats, they have never reported any capsize due to stability. Especially the houseboats, it has never capsized because of lack of stability. So, how can you conduct a stability test on a houseboat as per international rules? Absolutely not possible. We need to draft something, a new system to ensure the stability part, so that the insurance people will have some kind of supporting documents. We should understand the role of classification society in any vessel. The classification society makes sure the hull and machinery part, everything is perfect, so that the vessel can be insured accordingly. Here, the class is in the picture, but since the vessel is less than 24 meters, they don't have any responsibility on the stability part as per the existing rules.
Certified by third-party independent body as per the rules does not mean that the boat is 100% safe for operation, as most of these rules are outdated. The role of the third party is limited to check the boat as per existing rules. Even though we have rules updated internationally, it was not implemented till date in our country for inland pleasure vessels. Let's have a look at what investigator has to say on this.
I could find out was the vessel was having a list towards the starboard side around 2.9 degrees. So this list I wanted to substantiate in presence of the IRS Classification Society and also the designer to conduct a joint survey with IRS surveyor and the designer. So we did the survey on 14th, and there was some water inside the tank, so we emptied it and cleared the whole boat. And then finally we took the inclination. The inclination was, the angle of list was 2.1 degree towards the starboard side. So in order to conduct the inclining experiment, we had to bring back the vessel to even keel condition, that is 0 angle of list. We put human weights, 310 kilograms on the port side of the vessel, and the vessel was brought to even keel condition. Now after that we conducted the inclining experiment with bags of 31 kilos each. 4 bags were placed on one side and 4 bags were placed on the other side. The normal course of conducting the inclining experiment, we conducted it in presence of the designer and also the classification society surveyor. This vessel, if the boat is loaded with 75 passengers and also extra 15 passengers, the angle of heel to one side will be 14 degrees. So that means the vessel is also already having an inherent heel of 2 degrees. So the total heel will come to 16 degrees. In such a situation, a person will lose the balance, and the people sitting on one side will suddenly will fall to the other side. That means from port side to starboard, all the people will be falling. And due to this fall, there will be a big momentum will be produced. And this momentum will turtle the vessel 180 degrees.
Generally, capsizing results from insufficient initial stability, lack of operational stability, and more often a combination of both. Contributing factors for capsizing are raising the vessel's center of gravity beyond a critical point, water flooding down through open doors, hatches or flush deck fittings, free movement of water in the hold or in the tank that is only partially filled, boat's incapability to handle and satisfy passenger crowding. Understanding and managing the stability of a vessel is critical to the safety of the vessel and the crew itself. Planning for stability should start from the initial design stage of a boat.
For the safe operation of a boat, one of the most important aspects that has to be studied is the stability of the boat. The stability of the boat has to be estimated in the very preliminary stage, that is in the design stage itself. In the design stage itself, the naval architect has to conduct a very preliminary study of the stability of the boat and ensure that the boat will be stable after its construction. For this purpose, the naval architect has to estimate initially itself what would the weight of the boat be, what would be its center of gravity, and initially itself have a check whether the stability is satisfactory. How do you check whether the stability is satisfactory? The stability check is carried out based on internationally accepted criteria which has been laid out by organizations like International Maritime Organization or the IMO, which is supported by various third-party approval authorities like the classification societies like Indian Register of Shipping, the IRS, the American Bureau of Shipping, ABS, or the Bureau Veritas, which is a French classification society.
The basic parameters required for boat design are loading capacity and configuration, operational environment including speed, wind, waves, endurance, how long should the maximum voyage time be. All these basic parameters are considered complying if and only if the stability of the boat meets the owner's requirement.
Once the vessel's construction is completed, we have to conduct an inclining experiment which can be simply called a stability test. The stability test is normally conducted by a naval architect, and the results of this stability test gives us the weight of the boat and its center of gravity after construction. So this inclining experiment has to be conducted after the vessel is floating and after all the complete construction of the boat has been completed. And this experiment has to be conducted normally in presence of one accepted third-party company like IRS or the ABS or the Lloyd's Register or Bureau Veritas, who are approved and internationally approved for approving these stability tests and results. And once the inclining experiment is conducted, using the results of the inclining experiment, we can prepare a stability booklet. The results of the inclining experiment, which are basically the weight of the boat, the center of gravity of the boat, once these are calculated, we can use these values to calculate the stability booklet, to calculate the stability conditions of the vessel and check whether the vessel has satisfactory stability or not.
Basic design formulate the foundation of any structure, be it a building or a vessel. But if the design is faulty, no structure can withhold its existence. It definitely tends to crumble down. Something of a similar nature has happened with our ill-fated boat. According to our experts, it is the basic foundation of the boat which had loopholes in it. It is indeed surprising to note that the overall faulty boat still stayed afloat during its starting days. Let's hear from our experts regarding their conclusion on the design and the overall faults which they have deciphered from the ill-fated Jalakanyaka.
The main failure was that there was no naval architect involved in this project, right from the tendering stage till the handing over the vessel. So if a naval architect had been there, he would have definitely been cautious about the stability of this vessel. He would have conducted an inclining, he would have insisted on conducting an inclining experiment, a stability booklet, a stability certificate. All these things would have taken place automatically. Now the builder has made substantial changes on the design while he built the vessel, but this is quite normal. But he should have taken the advice of the designer while making these modifications. For example, there was a staircase in the middle, and this staircase was weighing maybe around 150-160 kilos. This was shifted over to the starboard side, and simultaneously he put a bilge pump on the starboard side, and there were changes in the seating arrangements which led to an imbalance of weight of 351 kilos to the starboard side. Now this led to an inherent angle of a list of the vessel, 2.1 degrees to the starboard side. Now, in order to compensate that, what he did, he put 3 seats on the upper deck on the port side. Major mistake of his was, there was a clause in the building contract saying that he should have a stability certificate from the IRS. Now, he did not ask the IRS for a stability certificate. So, he did not ask the designer, he did not tell the designer about this. So, designer did not make any stability information booklet, and this was not sent to the IRS for approval. And eventually what happened was, the total stability of the vessel was ignored. As per the hull certificate, all the hatch openings on this vessel should have been closed weather tight. It is written in their own rule book. But there was a big hatch opening. There were 5 hatch openings on the vessel, but none of these hatch openings were weather tight by giving nut and bolt. But what exactly happened was, there was a big hatch opening on the middle of the boat. On both sides, people were sitting. So when the boat heeled 90 degrees, this hatch opening opened, this hatch cover opened, and the people sitting on the port side fell into the engine room. And when the boat took a 180 degree turn, due to the hydrostatic pressure, this hatch cover came and closed again. So let's take, he's fully loaded 75 passengers sitting. His calculation shows that the angle of heel is only 8.5 degrees. But after doing the inclining experiment, this angle of heel is 14.51 degrees with 75 people sitting, crowding of passengers on one side. That means, if on the starboard side or port side, all people are sitting, and the people on the other side, if they just stand and come into the middle, the vessel will have 14.51 degrees, and at that particular moment, all the people will lose their balance. They will be thrown to the starboard side, and due to that momentum, the boat will be tilted 180 degrees. This is exactly what happened.
According to the researchers, Jalakanyaka was faulty from the very beginning. The boat was not properly insured, nor did it have the basic fitness certificate which could let her float in the calm backwaters. Then, why did the owners of the boat knowingly put so many lives at stake? In the wake of the tragedy, it has also been noted that the designer himself did not monitor the building of the boat. The small fault neglected by the authorities who came in to certify the vessel finally resulted in endangering many innocent lives that came down for a pleasure trip. After the tragedy, the authorities assured that the Kerala Inland Vessel Act 2010 will be implemented strictly so as to ensure maximum safety of waterway transportation and travel. Ensuring safety of existing boats and passengers, facilities to provide tickets to passengers and registration of boats are some of the important features of the Act. All the 4,000 odd boats operating in the state's inland waterways were asked to comply with the new norms prescribed in the Kerala Inland Vessel Rules 2010 for obtaining or renewing licenses. It was also decided that a committee headed by marine engineers and naval architects will inspect the boats prior to issue or renew of licenses. It was also made mandatory to do an inclining experiment to ascertain the actual center of gravity and weight of the boat. A dynamic analysis too is done to test the boat's stability when passengers crowd to one side, or if a strong wind blows or the boat takes a sharp turn. This is because a boat that looks safe in static condition could become dangerous in dynamic conditions. But how far are these strictures complied with in right earnest by the boat operators and implemented in letter and spirit is the crucial question.
It is after one year has passed by after the Thekkady tragedy, and during this 1 year, major changes have taken place in our maritime sector. So the main thing which was happened is the formation of Kerala Inland Vessels Rules 2010. Now there are 3 major aspects which has been covered in this new rule. The first one is ensuring that any vessel will not sink, any vessel should not capsize. These are if these two aspects are maintained, then we can ensure that the vessel is already safe. These two aspects were not covered in the previous rules. So these were the major things which has been incorporated in Kerala Inland Vessels Rules 2010. So in order to ensure that the vessel will not sink, there are naval architecture calculations which is called a flooding calculation. Any vessel the hull is divided into compartments, and we ensure that even if one compartment is flooded, in the case of an eventuality, the vessel will not sink. Now secondly, we have to ensure that the vessel will not capsize. For that, during the design stage itself, we do a stability calculation, resulting in a trim and stability booklet. Now after the vessel is completed, the vessel will undergo an inclining experiment, based on which the trim and stability information booklet is updated, and we ensure that the vessel will not capsize, even if in a worst case, for example, if it is a passenger vessel, if all the passengers are coming to one side, or wind is blowing, or if the driver is taking a sharp turn, a combined effect of all this will not capsize the vessel. So these are the two major changes which has come in the rules. Then the third major change was, so far the vessels were being inspected by mechanical engineers who were not qualified in this field. So this stability aspect and the other aspects of the ship can be ensured only by qualified naval architects or marine engineers. So this was another major third change which has come in, that is the vessel should be inspected and surveyed by qualified naval architects and marine engineers. So incorporating these rules, the Kerala Inland Vessels Rules, first of all, the draft rule was published, and the time was given for the public to respond for any changes. At each stage of this, the Honorary Court also intervened, giving directions and time limit. And finally, the final draft of the Kerala Inland Vessels Rules 2010 was gazetted, and after that, the handing over process from the Chief Inspector of Boats to the Director of Ports, who is now in charge of implementing this rule, also taken place with effect by 15th September of 2010. So that means the implementation process has already taken place in letter and spirit, and the new team of surveyors consists of naval architects, marine engineers, and master mariners, and they have already started the work of inspecting various boats in Kerala. Now during this 1 year, this is actually in what is happening in paper. So we have to ensure that these rules can be applied in the case of boats. Now we have got two categories of boats. One is passenger boat, and the other is tourist boats. So what we have done is that the tourist boats means our traditional houseboats. We have applied this rule for the design and construction of one houseboat which has been manufactured in Alleppey, and this has sailed through the sea to Maharashtra tourism. Then secondly, for the passenger boats, we have already built and launched two passenger boats for the Kerala State Water Transport Department. The construction of another 8 boats are going on in Silk, that's in Kannur. The order under the Jawaharlal Nehru Urban Renewal Mission Program, it is earmarked for another 40 numbers of boats to cater for the needs of the Water Transport Department. So these are the major changes which has taken place during this 1 year. Of course, regarding the other statutory requirements, they have already been very detailed, mentioned in the rules. So in a nutshell, we can say that even though it was a tragedy which took place in Thekkady, we have got very good positive results during the last 1 year.
Coastal waters to stringent checks and regular maintenance as per the prescriptions of the law. Yes, it's time for introspection and ascertain whether we have learnt lessons from Thekkady. If not, act right now before it is too late. Let's build safer boats and comply to rules to avoid mid-water tragedies in the future.